so hopefully everything works out. Coach Everly wants to order uniform shirts for all the players. P. On our women's lacrosse team, each shirt costs $20. There's an additional cost of $D for a player to put her name on the shirt. Use the steps below to write an equation for the total cost C if every player on the team orders a shirt with their name on it. So the first piece of instruction here is I want you to circle each of the variables that are in this word problem and then underline what those variables represent. Okay? Circle the variable and then underline what each of those variables means. Circle the variables. Circling the variables shouldn't require a great amount of effort. You just go through, for all players P, there's one, and then we have D is another one, and C. P represents all the players, D represents the additional cost, and C represents the total cost. Okay, so that's all there is to that. 2 wants us to write an expression. Expression doesn't have an equal sign, so we're not wanting an equal sign, we're just wanting to set up the expression that represents the cost of one shirt with the player's name on it. So the cost of the shirt up front is $20. Okay? Plus, what is the additional cost? Katie? D. So that's how we would set that expression up. 20 plus D. Now use the expression that we just came up with to write an equation that can be used to find the total cost if every player wanted their name on the back of their shirt. So we're still going to have the same cost here that we have, and that will go here, 20 plus D. That's still the cost of the shirts. And then Ethan, how many players were there?
We don't know.
We don't know. So what do we use for that?
P.
Right. So we put letter P there for players. And then all of that equals the total cost. They already put that in for us. All right. Moving on, number 4. Suppose the total cost for 15 players, so they're giving us one of those variable amounts now, right, aren't they? 15 players, to buy a shirt is $420. So they're giving us a number, 15 players to put in here. They're giving us the total cost to put in here. So let's do that. 15 players times $20 plus D is going to equal 420. That would be the equation that we could create to find the cost of the lettering on the back of the shirt. This is a common type of problem, everyday type of life problem that you likely will have and do it. You'll just do it. You get to the point where you just are able to figure that stuff out. Now, all I wanted was the equation. We're going to do the next step here in a minute with the rest of it. So what are we doing today? We're going to solve multi-step equations. We're also going to look at 2 other situations where you could have a problem that doesn't have a solution. Okay, there's not an actual solution for it. And then there's some problems that have situations where every number you put in would be a solution. Okay, so that's what we're talking about. Our regular old how do we solve for x or when we solve for x type thing is this one. That's what we've done since you started doing any solving for a variable. Okay, is you found what one number fits in for x. There's another situation though where if you work out the problem, you can get to a situation where you have a value that doesn't equal the other value. And if that's the case, then that means that's a no solution situation. No solution. It's the null set is the way that what they call that is a set. It's an empty set. There isn't any numbers that work for that. And then the other situation is if you get to a point when you're solving it where you see the exact same thing on both sides of the equal sign, then that's what they call the identity. When you look into the mirror, you see your identity. If you get a driver's license, that's your ID, your identity that they use. That's you. Here, you've got 2 equals 2. When's 2 equal to 2? All the time. Okay? 4x plus 2 equals 4x plus 2 is the exact same thing on both sides. That is what I'm going to call is any real number. How I would identify that. What are the real numbers? All of them. Any number. Every number. Okay? So any real number you can put into that equation for that variable and it's going to work out equal. Okay? So those are the 3 different situations or results, type of results you can get when solving an equation. One's the way we always have done it in the past, and then we have these other 2. Okay, so this is that problem we were just working on. And we just set up on the real world link. We had 15 players times the cost of the shirt, which is 20 plus D equals 420. So find the cost, the additional cost that it would take to put names on the back. Well, just like what we did on the bell work here, we cannot add the 20 and the D because they're not like terms. They don't have the same last name. You have 20 that doesn't have a last name, and then this guy just has his last name, not first name. So we can't combine them. So we have to be able to somehow perform this multiplication between 15 and that parentheses, and that's when we use the distributive property. If we're going to distribute the 15 times the 20, I'd use a calculator if we need to, but we don't because 15 times 2 is 30, and if we put the 0 on it, it would be 300. And then we have to distribute, I'm bringing a plus sign down, then we distribute the 15 to the D. 15 times D is just 15D equals 420. And then we are to a situation like the problem we worked on yesterday, where we just working solving it on out. Leo, what am I going to do to solve this problem?
You're going to minus 300 by itself and then 420 minus 300.
Good. We have 15D equals 120. And Adam, at this point we divide by 15. So D equals, is it 8 or 6? 8. So it's an additional $8 for the name on the back. $28 for a shirt, whatever. Oh no. Nope.
What the heck is that? Everything looks horrible.
Looks a little complicated, doesn't it? But what we have inside parentheses is what we need to work first, but we can't. Because there isn't anything inside either one of the 2 parentheses that we can combine. Because they're not like terms. Can't add or subtract the x and the 3 or the 3x and the 4. So how do we get rid of or perform a multiplication is to distribute. So we're going to take 6 times x is 6x. And then bring our minus sign down. Then 6 times 3 is 18. Plus 10, I'm just bringing that on down now, equals. And then distribute the 2 through. 2 times 3 is 6x. Minus, take your 2 times your 4 is 8. Anybody have any thoughts on what we need to do now before I start going to solving here? Katie?
Do no more with the X's.
I could, but there's something I can do before that. Anybody see what we can do to simplify, Ryan?
You can add 18 to 10.
Okay, let's go ahead and combine this. They're on the same side of the equal sign, right? So let's take our negative 18, and that is negative 18, not a positive 18. Negative 18 plus 10. Let's simplify that. So we have 6x minus 8 equals 6x minus 8. Hunter?
Can we add 8?
We could. You want to do that? We want to add 8, 6x equals 6x. And what was it Katie said?
You divide now.
Okay, we can divide 6 and 6, so you have x equals x. Haley? Other one.
There is a solution.
Amber? Identity. All numbers. So if I plug in 37 for x on one side, what's the value for x on the other side? 37, because x is 37, so both sides would have to be the same. We could have stopped right here. Aren't those two the exact same thing on each side of the equal sign?
Oh, yeah.
Yeah, they're the exact same thing. So they already at that point look the same, they're exactly the same. So we can say that there's all real numbers as an answer, or identity would be fine. I want to even go back to what Katie said here. She suggested, she was a step ahead, but I want to make sure you see that it would be okay. She said to subtract 6. Let's go ahead and do that and see what we get. If we subtracted 6x and subtracted 6x, you get negative 8 equals negative 8. When is negative 8 equal to negative 8?
When it's an identity.
Always, right? So it's an identity because you end up with something equal to itself. So that would be all real numbers, or any real number, or identity, however you wanted to word that. I'm okay with it either way. All right. One more crazy looking one, and I'll work through this one a little bit quicker. Again, can't add anything inside here, so I'm going to take 8 times 4 is 32, minus 8 times 2 is 16x, equals 4 times 3 is 12, minus 4 times 5x is 20x, plus 4x on the end there. I'm going to have my equal sign, that splits it in parts. These two dudes down here are like terms, so I'm going to simplify those. I'm going to rewrite everything else. So 32 minus 16x equals 12, negative 20 plus 4, and that means negative 16x. Okay. I left off the x on that one, didn't I? Now, if I'm doing what I had taught you guys to do, where we add our x's at this point, both of our x's go to 0. So I have 32 on this side, I have 12 on this side. Haley, what's the answer to this? No solution. When is 32 ever equal to 12? It's not. Okay. So since that's not a true statement, then that is no solution. Okay. If we had carried this on, I want to show you this real quick. Let's suppose that we didn't do the x's first, and you want to do a deal where, okay, I'm going to subtract 32 from both sides. Subtract 32. Then you have negative 16x equals negative 20 minus 16x. And then you added your 16x. negative 16x plus 16x is 0. Does 0 equal negative 20? No. So at whatever point you get to where it shows that they're not equal is when you'd realize there's no solution. I don't feel like messing with. Well, yeah, I better do this one. Huh? Yeah, we have 7 minutes. At the fair, Hunter bought 3 snacks and 10 ride tickets. Each ride ticket cost $1.50 less than the snacks. Which item costs more then? The snacks do, don't they? So if I were to just use a bar graph to represent those, and this is snacks, then I could draw the ride. I know the rides are less. They'd be there. What's the difference between the cost of the ride and the cost of the snack? Each ride ticket costs $1.50. So it's $1.50 difference between those two. Cool with this so far? Here's where it gets a little bit weird. Is I'm going to say that the snack price or the snacks equal the cost of the snacks. That shouldn't be anything weird. Okay. And that the ride would be equivalent to what? What would we have to do to the snack to make it equal to the ride? Ainsley? Take $1.50 away. So the ride would equal the snack minus $1.50. Okay? So the cost of the snack is equal to the snack. And then the ride is equal to the cost of the snack minus $1.50. So we're using snacks as our variable and our basic building block of this problem. So I'm going to get rid of this. He bought 3 snacks. Well, what's the cost of a snack? Class, what's the cost of a snack? Snack, isn't it? S. And then he bought 10 ride tickets. So he's going to have 10 times the cost of a ride ticket. What's the cost of a ride ticket? Snack minus $1.50. And that equals the total of, which we didn't get to, but the total of $24. And then we're going to distribute our 10 through because these aren't like terms. So I'm going to have 3s plus 10s minus 10 times 150 would be $15 equals $24. Do I have any like terms? Anybody with the same last name on that I can combine here before I go to solve? I have the s's here. 3s and 10s is 13s minus 15 equals 24. Now we just have a plain old equation that we should be getting more comfortable with solving. Add 15 to both sides. You get 13s equals 39. Divide by 13. And you get s equals 3. So the cost of a snack is $3. What's the cost of a ride? Less $1.50 would be $1.50. $3 minus $1.50 would be $1.50. Okay, your assignment. Listen closely. I want you to go to lesson 2-4. I gotta remember how I wrote down here. Lesson 2-4. I want you to do one problem from that. Number 5. And then I want you to go to lesson 2-5 and do problems 1 through 4. Now, look at problem number 3 on 1-5 or on 2-5. Sorry. See that it's got the house around it?
That means it's extra hard.
It means it's extra hard? No. But it is probably harder than the others. What does the house mean? Where can you go into to check it? Connect Ed. If you go into Connect Ed, your book, downloaded book, on that problem, you click on that house and it will show you how to work through that one. Okay? So that's the hardest one of them, I think. So don't be afraid to use your iPad to get that uploaded or to check on that. Still have 2 minutes. You can get a problem done. That's true.
Where do you want me to get, where do you want me to write?
I think, well, maybe Mrs. Renninger today. We'll see.
I've
Don't
been here
take
for
steps
years.
over.
This is my first
Usually it's my room, yes. It didn't work that way either. Thursday.
So we have it here for.
It did, yeah. I trust you. Pretty handwriting you got, Jackie. Wish I had handwriting that nice.
Oh, is that all?
Sorry about that.
It's okay.
I actually got it filled out today.
We leave in 6 minutes, 6 seconds. 3.
Garrett, not everybody's slow like you.
You should watch the movie. We're watching good movies today.
Yeah. Yeah. Come in,